Hi folks, welcome. This is a new series of videos about the Bach and Cage libraries in Max, and in general about algorithmic composition. In this series of videos, I want to start from the beginning. I don't want to assume any previous knowledge about algorithmic composition or using the Bach and Cage libraries. Why do we want to use Bach and Cage? Bach allows us to fill one of the gaps of the Max programming environment, which is there is no really native way of doing iterations in Max. Bach allows us to fill that gap. The second point is that with the Bach library and Cage and data, we can really have a lot of tools to do algorithmic composition thanks to the score objects such as the Bach roll and Bach score. Furthermore, these objects can all be connected to both DSP objects, so all of the tilde objects in Max, as well as Max objects. So it's fully integrated with the Max environment, which allows us eventually to also be able to do visualization of our compositions using Jitter and OpenGL. Maybe the most important aspect of using Bach is the ability to work with nested list. And this is an example of a nested list, which is a list of 3 items in this case, and each item contains a sublist. If we measure the length of this list by using the Bach print object, will give us a length of 3. If I add another set of parentheses around these 3 lists, length of the list in this case is 1, meaning there is one set of parentheses that wraps everything. It's important to understand how this works because as I do iterations, I will need to be aware of how this parentheses work when I iterate lists. So the opposite of the Bach wrap object is the Bach flat, which will get rid of all of the parentheses that I have. The Bach flat object will by default get rid of all of the parentheses that I have, but I can give the flat object arguments. So if I give the flat objects, for instance, an argument of 1, the flat object will only erase one set of parentheses, the outermost set of parentheses. So to understand how lists work, we can just use the Bach tree object, which gives us graphic representation of how the list is organized. In the first example, you have one item divided into 3. And the second example here, you have 3 different items, and each item contains one object. The object that I'm going to use to do iteration today is the map element object, which iterates and collects, and I can apply a function to its lambda outlet. We'll see about that in a little bit, but first of all, let's look at the max depth attribute. The max depth attribute is fundamental in order to understand how iterations work in Bach. By default, set to -1. The -1 max depth attribute tells the iteration to parse through the list until it reaches the smallest possible item, which is also called an atom. The attribute max depth 0 is a special case because it will actually consider whatever incoming list as a single item. And to do that, it will add a level of parentheses around the list. So in this case, you can see how the list that I've sent in has been added an extra level of parentheses around it. Max depth 1 is the one that I find is most commonly used. It leaves the hierarchy of the list intact, and it will just iterate through the items one by one without going into the item to look for smaller atoms. It will not add or eliminate any level of parentheses. The max depth 2 will actually start eliminating level of parentheses. In this case, it will eliminate the level of parentheses around the 1A. And so it will iterate and it will give me 1, and then it will give me the A, but the A will still preserve its parentheses around it. I can use this logic of parentheses to operate and do complex iterations. The Bach map element object for map element will iterate through the list and collect the list after all of the iterations are done. It will output the items that are iterated by the rightmost outlet, which is also named the lambda outlet. And the lambda outlet works in a way that I can attach a function, an operation to that outlet and expect that operation to apply to all single items iteratively. So in this case, I'm just adding a +1 to each one of the elements. So the map element object will output all of these elements, add 1 to all of them, and then output as a list. Importantly, it's preserving all of the parentheses and the hierarchy of the parentheses. So if I want to just add the first element of the sublist to the rest of the sublist, I can just first of all iterate the list using the argument max depth 1. Then I have to flatten the output of the lambda output in order to get the flat list. And again, just slice the first element, getting the first element from the lambda outlet, and I can use the second outlet of the slice 1, which gives me the remainder of the list, to add it to the first element. And that's pretty much it in terms of this task. I can just get the output from the left output of the map element, but I see that I have lost the level of parentheses that I was working with, so I might want to add that back in by using a wrap object, and there you go, I have the task accomplished. So I hope you will stay tuned for these videos. I'm going to move through different techniques and different aspects of these really cool libraries.